The solar system is full of rocks. But not all of them are large. Dust-sized particles shed from comets and asteroids, and smaller than a single grain of sand, traverse the solar system at speeds reaching 40,000 miles an hour. Our best knowledge of these tiniest meteoroids comes from measurements made near Earth. But a clever use of data from the LISA Pathfinder mission has tallied these particles nearly 1 million miles away. Launched in 2015 and retired in 2017, LISA Pathfinder is an ESA-led mission that demonstrated the technology needed to build a future space-based gravitational wave observatory, a tool for detecting ripples in space-time produced by, among other things, merging black holes. LISA Pathfinder was a resounding success, demonstrating it could keep its instruments steadier than any mission previously flown. It reduced unwanted forces on its instruments to less than 1/millionth of a billionth of the gravity felt on Earth. To do this, LISA Pathfinder had to isolate its instruments from environmental disturbances, including occasional micrometeoroid impacts. Each strike moved the spacecraft slightly, and it reacted immediately by firing small thrusters. The science team found and characterized 54 impacts over the mission's duration, shown here as yellow dots. LISA Pathfinder did its work while orbiting Earth's Sun L1, a gravitational balance point about 1 million miles toward the Sun. This is essentially unexplored territory for understanding the solar system's dust distribution. The science team was able to use data in between various other tests to search for dust impacts on the spacecraft, seen here as purple regions. The findings were broadly consistent with existing ideas of what generates micrometeoroids found near Earth. These models predominantly favor nearby Jupiter family comets, like 9P Tempel 1, 103P Hartley, and 67P Churyumov-Gerasimenko, as the main dust makers, with additional contributions from comets with longer periods, like Halley's Comet. Improving our dust knowledge will help future missions assess potential hazards for spacecraft operating in the inner solar system. It will also help us better understand the dust environments around other stars, which can complicate searching for planets around them. And the same technique can be used on other precision measurement missions. We'll learn a bit more about the solar system each time one of these spacecraft is struck by a microscopic comet crumb.